understood what is exactly a subquery and how to write different types of subqueries in MySQL. If everybody recollects, we have already seen that you can have a scalar subquery, an inline subquery, a nested subquery, and a subquery written as a common table expression. We have already discussed these four types of subqueries. In today's video, we will take a look at what is a proper way to format a subquery, what are the dependencies around subqueries. Then we will understand how to create views in MySQL. Then we will understand what are the trade-offs that you have to monitor when you create a subquery. And finally, an optimal strategy to create a subquery. So that's the entire roadmap for today. So let's begin. So to start things off, we'll first understand what do we mean by subquery formatting. We have already seen that when we create a subquery, we need to write multiple tables inside. We need to query from multiple tables and nest them one on top of one another. If it is not done properly or it is not done in a manner which makes it easier to read, it can become very difficult for the end user to understand what exactly are you trying to accomplish from that query. Right? So the first concept that you need to understand is basically the placement of the subquery. Are you placing it using the with clause, or are you nesting it? Are you using the inline one, or are you using the scalar one? So the placement of the subquery is essential to write a correct subquery. If you want to use a scalar subquery, then you will not actually use it in a nested format. Rather, you would essentially use it using the where clause like we had done yesterday. So the placement of the subquery is the first thing in which you decide how exactly are you going to put it with the outer query. So using the outer query, you can put it using the with statement, which is the common table expression syntax, or you can nest it within the from syntax and give it an alias, which we have already discussed in the last session. Or you can use it in an inline manner or a scalar subquery completely. So there are different ways of using a subquery. It depends upon the programmer to decide how exactly he or she wants to implement that subquery. The second concept is to understand is called indentation, wherein you need to properly indent your subquery. Not indenting a subquery will not give you any errors, because already I have said this multiple times that in MySQL, it doesn't matter how many blank spaces you write in a particular query, right? So they are all, when executing, all those blank spaces are trimmed down, and it does not matter if you have added a tab or a new line character anywhere in between a subquery. But you need to do it because it makes the query readable, right? So by properly indenting a subquery, you increase the readability of your subquery. And lucky for us, if you are new to that, if you don't are not exactly sure how to properly indent your query, MySQL has a tool on the home page which allows you to indent your subquery in a proper way. So first, I'll just give you a contrast of what do I mean by a badly formatted query. So here is a very simple query which is written, in which you can see that first I'm selecting in the inner query, but see in this case here you can see there is no new line which is added after the outer query, so that we can clearly distinguish where is the outer query ending and where is the inner subquery starting. But if you see here in the inner query, we are selecting the date trunc function and we are truncating the day. Then I'm selecting some count as event from the web events and I'm doing a group by. So properly understanding what is happening where and how it is actually you can say staged on top of one another is a little difficult to understand with this, because of the fact that you are writing everything in one single line without doing any new line characters or indentation here. And that's the problem. If you compare it with a proper formatted query, this is what a proper formatted query would look like. Here you can see outer query, we are selecting all the columns. Then here this is a nested query, as you can see, because the subquery goes in the from clause. And then you are selecting the date. You are selecting the day from a particular date. Then you are selecting the channel, and also you are selecting the number of rows here as events. And this you are doing from a table called web events after doing a group by and doing a order by. So here you are clearly able to identify, okay, what is the inner query, which table it is referring to, what columns you are selecting from the inner query, and how are you creating this inner query. And in the outer query, you are just simply selecting all the columns from the inner query. But it's much easier to read this as compared to reading this. Why? Because it's properly indented and it's written in a manner which makes reading a bit more easier, right? Although for you who wrote the query, it might be easy to understand the previous query as well. This query might be easy for you to understand if you are the writer of the query. But if you are someone who is actually looking at the query for the first time, then it will become a little difficult for you, and then you might have to first copy the inner query, execute it separately, then use it on top of the outer query, and then completely execute the query from top to bottom. So the understanding might take a little bit longer if you are executing the query for the first time. So now let me go back to the MySQL workbench, in which I can show you how to use a tool in workbench itself that allows you to format a query properly. So I am back in my MySQL workbench here. So remember in the yesterday session, we have written a lot of different queries, right? So all these are examples of subqueries here. So right now I already formatted them, but actually see this formatting was done by me manually, right? So I decided how to select and how to place each and every clause. But if you want that, let MySQL editor do the job for you. So there is an option on the top side here with this brush like icon is presented. This brush icon, if clicked upon, it will take it and it will actually format it in a much better way, right? So here if you see, I just simply clicked on that brush icon here. This was the query before the formatting. If I just click on this brush icon here, it will completely format the query again. So here you can see, here in the outer query, we are selecting some columns. This is the table, which is the outer table. Then I'm writing a select statement wherein I'm selecting a value from the inner table. I'll come to the table, come to this query later on in order to explain what is going on in this query. But here you can clearly see this query is much better formatted, simply because here MySQL has a set of rules which has defined to properly indent the query depending upon the clause, depending upon the nesting and all those. So you can directly use this tool to properly format any query that you want, right? So it does not matter how big or small the query is. So here you can take another example. So this is a common table expression. So from here till here, so if you remember, we had written this big common table expression in which we had written two nested queries, or two derived tables we had created. Here you can see we had created two derived tables, and then we use these two derived tables to run an outer query at the bottom here. So if I want, I can even reformat this and actually convert it into more readable format. But here right now it's already formatted properly, so it's not changing anything. But yeah, if it was not, then it would have actually reformatted it in a much better way. Right now it's already formatted properly, so you're not seeing any changes. But had it been that you had not properly formatted it, it would have converted into a much more readable manner. So you can use this brush icon to reformat any query that you have written in MySQL Workbench. So now we have understood what do we mean by a bad formatted query and a good formatted query, right? So this is a well formatted query. So we have already seen the differences between the two. So now the main idea here is to make sure that each and every clause is readable. From the clause, I mean select is a clause, from is a clause, where is a clause, group by, order by, all these are clauses. And whenever you create a new clause in a query, make sure that you write that clause in a new line and you properly indent it with the level of the query it's supposed to be in. So if your group by is a part of a nested query, then that group by should be indented towards the level of the nested query. Don't keep that group by at the level of the outer query. Otherwise, the reader will think that you are running the group by for the outer query. If it is indented till the inner query or the nested query, then the user will properly understand, yes, you are running a group by for the inner nested query. So any clause that you write, be it where clause, group by, order by, having, any clause, make sure it's properly indented at the level of the query that you want to run it for. If you're running it for the outer query, indent it to the level of the outer query. If you're running it for the inner query, indent it till the level of the inner queries. So properly indenting the clauses is basically what makes a query readable. And the second part here was called dependencies. So as I already mentioned this term in the last session as well. So a query can be of two types, or a subquery can be of two types. It could either be a simple subquery in which the inner subquery can run independently of the outer subquery. All the examples that we had discussed in the last class, they were all examples of simple subqueries in which you can take or copy paste all the subqueries and execute them standalone without writing it inside an outer query. That is what a simple subquery means. So it's an inner subquery which is completely independent of the larger query. Other example or other type of subquery is called as a correlated subquery. In the last video, I was not able to present some examples that I'll do today. So in a correlated subquery, the inner query is dependent on the larger query. That is, first you will run the outer query, take each row from the outer query and execute the inner query depending upon what value you are getting in the outer query. So this will become a little bit more clear with an example. So I'll get back to MySQL Workbench and give an example of a correlated subquery now. So now we'll talk about a correlated subquery, and this is what a correlated subquery would look like, right? So what am I trying to do in this correlated subquery? Let me increase the font size. So here I want to print all employees which are earning more than their department average. Here if you see what I want to do, I want to filter out details of employees who are earning more salary than their department averages. So for each employee, you have the department of the respective employee. So I want to filter out all employees who are earning more than their respective departments. Now there are multiple ways of writing this query. You can write it in a simple subquery manner as well, and you can execute it in a correlated manner as well. So first I'll execute in a correlated manner, then I'll also tell you how you can write this query in a simple manner as well. So here you can see first I start with the select statement. In the select statement, I'll select the employee ID, first name, salary, and department number. So these are the columns that I'm selecting. And this selection I'm doing from my employee table because I want to filter out details from the employee table only. So what details I'm filtering out? I'm filtering out my employee ID, name, salary, and department number. Right, this I'm doing from the employee table and I'm giving it an alias called outer table. This alias is not mandatory, but it is required here because we are going to use it in the nested query later on. So it's not always mandatory to give an alias to the outer query, but here we need an alias here because we will use it somewhere inside. So now once we have filtered out the information from the outer table, what we are doing here, if you see, I'm then writing a where clause. So this where clause is for the outer query itself. So if you see here, this where clause is for the outer table. In the where, here you can see I'm filtering out only the rows where salary is more than this particular value here. So if you see, this is an example of a scalar subquery first of all. Why is this a scalar subquery? Because the output here is the average here, right? So we are calculating a scalar as the output. So this is a scalar subquery which I'm writing. In this scalar subquery, I'm comparing the current salary of a row with the average of a particular group by statement. Now, how am I calculating this average is basically what makes this statement as correlated. So if you look at the nested query here, I'm writing select average of salary from the employee table again. But this time, how do I calculate the average? For calculating average, I'll filter out only the rows in which the department number matches the department from the outer table. So remember, in the outer table, we are going to execute this query row by row. So how the execution goes is that MySQL will start taking each row one by one from the outer table. It will take the first row of the outer table. It will take the department number from the first table, first row, use that department number to filter out the rows required for the inner table. So here you can see the execution of the inner table depends upon what the department number is from the outer table. So whatever department number we get from the outer table, right? So here the outer table will give us a department number for a particular row. That department number will be used to filter out rows for the inner query. So here, as you can see from this inner employee table, we are filtering out only the rows where the department number matches the department from the outer table. And for those rows, we calculate the average salary. So indirectly, for each department, we are calculating the average salary for that respective department. So the way it will execute is like this. That is, let me write the select statement from our employee table. Simple select statement that I'm writing. So here, if you can see, this is the first row of this employee table. So the first row employee table, the department number is 5. So what it will do, it will take department number 5 and it will filter out all the rows in which the department number is equal to 5. That means the highlighted rows that I'm showing right now. So all these highlighted rows will be passed to the inner subquery, and inner subquery will return the average of these values that I'm highlighting. And this value will be used to check whether the current salary is more than the average that I have computed from the inner subquery or not. So if you come here and see the output, so here what we are doing for all the rows that are filtered out, I'm calculating simply the average here using those, and the filter condition is going like this. And finally, I'm doing a group by department number. So here you can see I'm doing a group by the department number, and this group by will tell me what is the average salary for that particular subset of rows. And you take that average salary and filter out only the rows in which the salary is more than this average. So if I execute this query now, you will find that in the output we only have the employees who are earning more than the department wise averages. All right. So this is a correlated subquery, and why is this correlated now? Because for each row, the department number will change, and hence the query which will run for the inner query, here you are actually utilizing the value from the outer table. So some value from the outer table is getting utilized in the inner table, and that makes the inner table dependent on the execution from the outer table, right? So here it will execute from the outer table first, get the department number, and execute that on the inner query, filter the rows from the inner query, and then allow it to show the outer query results. So here the final output here will be containing the employees who are earning more than their department-wise averages. This is one example of a correlated subquery. I have another example as well. So in this another example, I'm trying to filter out all the employees who are at least reporting, or all such employees who have more than one teammates within them, right? So remember, for each employee we have the information about their manager ID. So we want employees who are reporting to a particular manager. So in this example here, what I'm doing is that in the outer query, I'm selecting some information from the employee table again. So we are selecting employee ID, first name, last name, department number, and the supervisor ID. And then this outer table here, the condition which we are writing is exists. So exists is going to check whether the inner subquery has returned any row or not. So is it returning me a none, or is it returning me a non-null value? So if it returns me a null value, exists will return you a false. If the subquery returns, if the subquery returns a null value, exists will return a false. If it returns some non-null, that is some rows are returned by the inner query, then it will return you a true. So here what are we trying to do is that we are filtering out these columns from the outer table: employee ID, first name, last name, department number, and supervisor ID. This I'm doing from the employee table. Then I'm checking if this outer table supervisor ID is matching with some employee ID or not. Remember, each employee will have a manager, and I want to filter out all employees who are actually working for that particular manager. So here, whoever is the supervisor ID for that employee for the current row, I am checking if that employee is existent in my employee table or not. So where SSN matches the outer table dot supervisor SSN. So this will check whether the supervisor ID that I have mentioned for that employee, is it existent in my employee table or not. If it is existing in my employee table, then it will return me some X, right? So this is just a random string that I'm returning if that employee ID is present in my inner table. Right? So here you can select anything that you want, but here we are not using any column as such from the inner table. Here we are just checking if the outer table's supervisor ID is matching with inner table's employee ID or not. If it does, then I will get some non-null value here. If it does not match, then I will get a null value. So here exists will return me a true if this returns me X, otherwise it will return me a null value. And a row will be there in the output if this supervisor ID is actually matching with an employee ID from the inner table. So if I execute this query now, here you will see that I will have all the employees who are actually reporting to some manager. So here for the first example, here you can see the supervisor ID was 3334455, and this will match against this particular employee ID. So therefore, inner query will return me a true for this supervisor ID. Similarly, for this supervisor ID, it is matching against the supervisor ID it will match against a supervisor ID from the employee table, although that employee is not available in this because he does not have a manager, right? So let me show that as well. So why are we not getting this employee ID in the result set? So for example, let me select star from the employee table. So here if you see, this is the first employee ID, supervisor manager. So if you take this one, it will match against the supervisor ID, is match against this employee ID here. So these two values are matching here. So therefore, this row will be there in the output. So first row is in the output. Why? Because the supervisor ID of this employee is available as a employee ID. But for the second employee here, if you see this supervisor ID here, although it is there, but here if you try to match it, what will happen is that this employee ID will be a null value. So actually in this example here, if you see what is happening underneath this inner query, so we are actually matching the outer table supervisor ID against an employee ID, and we are selecting it if it is matching it. So actually for that employee, the supervisor ID is null. So therefore we are not getting that value in the output. For all the other employees, we are matching the supervisor ID with an employee ID, and that's why we have it in the output. So that again becomes an example of a correlated query. because the outer table dictates which rows are getting selected from the inner table, right? And then the selection from the inner table is used to calculate the outer table. Now that's what a correlated query is all about. So it's basically about understanding how the execution of inner query is happening with respect to the outer query. If the inner query is executing completely independent of the outer query, it's called a simple query. If the execution of the inner query depends upon the values that you are getting from the outer query, it's called a correlated query. Now we want to avoid writing correlated queries as much as possible, right? So you don't want to be writing correlated queries a lot. The reason being, when correlated query is executed, for each row of the outer query, the inner query is run every single time. So if the outer query has millions and millions of rows, then effectively you will execute the inner subquery that many number of times, which is a very time consuming process, and we don't actually recommend writing correlated queries a lot. So therefore, we avoid writing correlated queries simply because the execution time of correlated queries is very high. Again, understanding that because unless an inner query is run, your outer query will not run properly. So you need a value from the outer query. That value is picked for each row one by one, and for each value of the outer query, you execute the inner query. Right. So the complexity of this query is very high as compared to a simple query wherein you run the inner query only once and use the results from the inner query to independently execute the outer query. So there is no dependence of inner query on the outer query. So therefore, inner query also will execute just once, and the outer query will also execute just once. Yeah. So now we have understood what do we mean by simple query and what do we mean by correlated subquery, right? And a subquery can either be simple or correlated. It's better to keep subqueries simple to first increase the readability and also reduce the execution time of your query. So from both the perspective, simple subquery is much easier to interpret as well as execute as compared to a correlated query. So when to use a correlated query? So when you it's slick to include a correlated subquery, specifically when the value of the inner query is dependent on a value outputted from a main query. So the way you try to find how to execute a subquery is that if you want to have a subquery such that the value that a subquery is utilizing is dependent on the outer query, then only you should write a correlated subquery. Otherwise, just convert it or try to convert it into a regular subquery or a simple subquery. All right. So that's all about subqueries here. The next topic for discussion is called as views. And why do we require views? Let me first give you or talk about that. So remember that when we create a subquery, a lot of the times we require we actually want to create some temporary tables as well, right? So from a temporary table, what do I mean by temporary table? A temporary table is one which is created during the execution of the query, and as soon as the query execution is done, that table is deleted from the memory. So such a functionality is useful when you want to use that temporary table only once, right? So if your temporary table's requirement is within that subquery itself, then it's well and good. You can write it in a format like we have discussed already, right? So you can either use a common table expression or a nested subquery to create a temporary table, execute an outer query by using the results from that temporary table, and allow MySQL to delete that temporary table permanently from your memory. That is well and good. But what if your requirement is that you want to create a separate result set, right? So you want to create a result set and you want to use that result set to further perform more analysis, right? And you require to use the entries from that result set in multiple queries, right? So let's say you want to write 6 different queries which use the same result set that you have received. Now, one thing that you can discuss here is that yes, okay, let's create 6 subqueries wherein I write uh, the same result set as a common table expression in 6 tables, and then execute an outer query which is using those common table expression. This is absolutely fine. There is no problem in doing that. Just one drawback is that for every time you write or execute a new query, you will duplicate or re-execute the same common table expression again and again and again, which is not ideal because why waste time, right? So that's where views come into picture. So what is exactly a view in SQL? So view is like a table which is not stored on a database, but rather it is stored on your memory permanently for that SQL session that you are running. So remember, every time you log into MySQL server, you are actually running a session, right? So you are communicating with the SQL server at the backend. So there is a session which is going on, right? So when you execute any queries, you are executing those within that session. Now, as long as the session is active, that table will remain in memory as it is, and you can run n number of queries on top of that view without having to recreate it every single time. All right. So in this case, assume you run a complex query to fetch data from multiple tables. Now you'd like to query again on top of the result set, right? So rather than executing the same complex query again and again, you convert that complex query into a view and run as many queries as you want on top of that view, right? So you need to store that view temporarily on your RAM as long as the session is active. And once the session is closed, that will be deleted, but you are not storing on your database, right? So it's temporary from the perspective that you need it for the current session only. You don't need to permanently store it on your database, but you need a way to keep a table in memory for multiple queries that you want to execute. So that's where views come into picture. So here, how to create view? So here, view is it doesn't. So as I already mentioned that when you create a view, it doesn't actually exist physically in a database. View is only created in your in your RAM or memory, and as long as a session is active, that is, you are currently logged in with your account in MySQL Workbench, that table will remain in RAM, and as soon as you log out, that will be removed from your RAM. All right. So how to create a view? Creating view is extremely easy. Just like you create a temporary table by using the as syntax, here also you need to use the keywords create view. So for creating tables, we use the keywords create table. For creating database, we use the keywords create database. So for creating a view, we have to use keywords create view. After these two keywords, we write a name. So here you can see you write the name of the view. You can use any name that you want, whichever you feel is the easiest to remember. You can use that name over there, right? And once that name has been selected, it will create a view by using that name, and then you define the body of that view. That is how you want to populate that view. This can be a select statement, like this, in which we can create group by joins. This is basically like a normal query which is producing some result set. Right? The select statement could be any complex select statement that you have in SQL, and then the results from this select statement will be put together inside a view, and that view will be used there. Right? So every time you create a view, that view will be triggered whenever you want to use that view. You can use that view as you use any other table in MySQL. So that will become clear in a moment when I share the screen for the workbench. So now let me go back to MySQL workbench and we'll discuss how to create views as well. So here, if you see, I'm creating a couple of views here, and these views will be created with increasing complexity. So first, I'll create a very simple view just to demonstrate how a view operates. Right. So in this example here, I will create a view, call it as employee view. So I can name it anything I want. Right. So this view I can give any name that I want. So this is employee view. You can write whatever you want. And then after that, create view employee view name. You write the as keyword, and then you define the syntax that is going to populate this view. So in this case, I'm currently selecting all the rows from the employee table. So it's basically like I'm duplicating my employee table for now. Why am I doing it? Because it's the easiest one to understand, right? So when you create a view by copying one table, it's the most simplest of views, but you can create more complex query as well. So let's say you want to select all rows from the employee table where gender is male, right? And let's call this male employee view. Now this is a view that I'm creating in which I'm filling or selecting all the columns from the employee table where the row is a male employee. So for all the male employees, I'm creating a different view here. So if I execute this query over here right now, and I refresh this particular column here, so you can see that the view is created on the left hand side panel. So in the database here, you have a section called views, which will list down all the views that I have created for the current session. Remember that these views will remain only for the current session. If you log out of the session, this will be deleted, and you can see male employee view is created because this is the view that I created right now. Now, once this view has been created, you can use this view like you use any normal table in MySQL, right? So I don't have to recreate this view every single time I want to utilize it in some outer query, right? So let's say I want to calculate the average salary of all the male employees. So all I can do right now is that I can use the average of the salary from the male employee view. What this will do, it will select the column of salary, calculate the average of it, and this it will do only for the rows present in the male employee view. So if I execute this row now, here you can see this is the average salary for my male employees. If your view was not there, in that case, you would have to first filter out the rows for male employees and calculate the average salary using those rows which are filtered out. So creating a view creates a temporary table for you, which is stored in your RAM, right? And you can use this temporary table like you use any other table in your database. Once created, it is available for you to use n number of times wherever you require it to be used, right? So in this case, if you want to join it with some other table, let's say you want to select star from male employee view, do an inner join with the locations table, or let's do that with a dependent table. So in this case, what I'll do is that let's do an inner join between this table and the department table. Department on male employee view dot department number matching the department dot d number. So here I'm trying to append the department information to the male employee view as well, so that I need to know, okay, which departments they are working in. So here you can see these are all the rows that are coming from the employee table, or the male employee view rather, because these are the rows only for male employees. And I'm appending the columns corresponding to the department information to the same view. So the output here is a concatenation of two tables. The first table is the male employee view. Second one is the department table. This department table is permanently stored in our database, whereas this view is created temporarily for the purpose of this session only. All right. So this is how you create and use views, and you can create more complicated views as well. So let's say you have created a view which stores the department-wise averages. So here you can do select department number and average of salary, and just call it as average salary from the employee table to a group by department number. So here this expression will do what? This expression will return you the department-wise averages that we have. Now, what if you want to put them in a view somewhere, right? So you want to put them in a view. So here you can do create view. Let's name it department average, department salary average as. Then I'll put the brackets here, and inside these brackets, I'll basically put the definition. So here you can see I have basically created a view. So here you can see I have created a view which is called department salary average, in which I'm selecting the department number and the average salary from the employee table and do a group by the department number. Right. So here what it will do is that it will create a view for me. So I execute this query here. I refresh this query. and you can see the view contains two columns now. So department number and the average salary. So if you want to print it, you can simply run the select statement, select star from department salary average. And here you can see these are the averages. Now, if you want to do the same example that we did in our correlated subquery case in which we are printing rows for employees who are earning more than their department-wise averages. So what you can do if you want to convert it in a simple subquery, so you need to first join this with the employee table. Right? So I want to select, let's say, star from employee table, inner join it with my department underscore salary average on employee dot department number equals department salary average dot p number. So here what it will do, it will first create a table in which your employee table columns will be joined by the columns that this department salary average has. So if I just show you the output right now, so here you can see in the output, we have all the columns from the employee table, plus we also have what are the department wise averages. Now all we need to do is filter out rows where the salary is more than the average that we have put here. So for any row where the average is higher than this average salary, that row we want to filter. So what you can do here is that you can simply you can write a condition here called where, and you can do employee dot salary is greater than uh, department average, department salary average, average salary. So if you run this query now, so here you will see we only have the rows in which the salaries are higher than the average salary. So this is a simple subquery. It's not even a subquery, rather it's basically a join which we have written, in which we are utilizing the results from this particular view which we have created. Right. So this is how you can actually convert a correlated subquery into a normal simple subquery. So it depends upon your thinking perspective. If you can think how you can create it. So it's not, there is no thumb rule which is there using which you can convert any correlated query into a normal subquery. So you need to understand how that query is working at the backend, and try to think about, okay, is there a way in which I can remove the dependency between the inner query and the outer query. That is something that you have to think of. There is no thumb rule that is you can use to convert any correlated query into a simple query. I hope this makes views clear to everybody. So what exactly are views and how to create and use views inside any queries that you are writing. Yeah. So now in the last slide, we have already seen how to define a query, and you can, once it is created, you can use that query as a normal table. So once you have defined your view, you can use that view just like you use any other table in your database. So it will not have any impact whatsoever on that. Now there's a couple of points that you need to remember here. So if you update a table by updating a view. Let's say you have created a view, and in that view you want to make some changes to the rows which are stored in that view. So by changing those rows, will it have any effect in the rows of the main table from which it is created? The answer to this question is it depends. It's not guaranteed that on changing any rows in a view will it change. It will not change the base table. So ideally, what I recommend to everybody is that if you want to make any changes to a view, just go and make the changes in the base table and recreate the view. Because otherwise, you cannot decide beforehand exactly when updating a view will update the base table or not. Because sometimes, let's say you update a view and then accidentally that update operation updated the inner table as well, which is not something that you desire, right? So that is something that we don't want, and therefore to avoid such problems, just avoid updating a view directly. Right? If you want to make any changes, just make changes to the main table only. Don't use update operations on your views as such, because you don't exactly always know when it will update the main table or not. Ideally, what happens is that whenever there is some aggregation which is there in your view, so aggregations like group by or join, right? So some complicated queries are there in which you are bringing information from more tables using join, or you are aggregating using a group by. In such cases, the view may not update the underlying base table. So once you have created a view, on updating the view, the underlying base table will not be updated. When it will occur, when there is any aggregation or join available. But if not, then it might be possible that your views can update the base tables as well. So if you don't desire that, please avoid or restrain yourself from updating views directly. All right. So now here, the last topic is understanding what are the trade-offs when it comes to subquery. So the trade-offs which we will discuss here basically are on the 3 points. First is the readability, meaning that how easy it is to determine what the code is doing. Right. So whenever you write any subquery, and you want to know whether the subquery, you have two ways of doing the exact same thing, right? So you, for example, I had shown this that you can filter out all the rows of employees who are earning more than the average salaries of the respective department. You can write both a simple subquery as well as a correlated subquery for performing that task. So in order to understand which query to choose, do you choose a simple subquery or do you choose a correlated subquery? There you have to talk about these 3 trade-offs. The first is the readability. Which query is easier to understand? Whichever it is, that gets a preference. The second one is performance, right? So how quickly the code runs, the faster the query can execute, the more preferable it is to have. And last is a query plan, in which we try to understand what is happening under the hood. That is, we try to understand how many times the inner subquery is running. Right? We want to avoid multiple executions of the inner subquery so that the overall runtime of that algorithm is less. So please keep a mind of how the query is executing. You need to have a query which is executing in smallest amount of time. You don't want to give too long for a query to run, because otherwise the analysis will take further that long. Right? The trade-offs are based on readability, performance, and query plan. Now there is a guide which you can use. The link to this guide is there in the slides. right? So if you click on this link, you will be directed to a page which tells you about all the optimizations that you can do when it comes to writing optimum subqueries or optimum queries in SQL. We cannot have a dedicated session on this because it will eat up the complete session. So I'll recommend you going on to this guide and reading in detail about what are the different optimizations that are available for you to optimize any query that you have, right? Once you start reading, you will be able to get the topics. There is no problem with that because all the optimizations internally, when you write those optimizations, they are nothing but SQL statements only. So if you have understood what we have covered in the last 6 sessions until now, right, then you will be able to get all the optimizations that I just mentioned. Now let me give you a quick example of what do I mean by an optimization as well. So here I'm going back to my workbench here, and I'll give you a small example of how you can optimize a query. So remember here in the last query which I executed, in which I was filtering the employees who are earning more than the department-wise averages. Here you can see after doing the join, I am writing a where clause which is filtering out rows in which the current salary is more than the department-wise average. Now if you understand how this query will execute, what will happen underneath is that it will first join the employee table with the department salary and then filter the rows from the joined table, right? So it will first join both the rows, that is the rows in which the salary is less than the average and the salary in which the salary is higher than the average. So both type of rows will be joined together, and then out of that joined table, only the rows in which the salary is more than the average will be filtered out, which is not optimum way of doing it. A better way of doing it would be what, that at the time of joining the two columns together, if there would have been a way to understand, okay, if the salary for the current row which you are trying to join, is it more than the average for that row or not? And that is how you can actually write it like this. So if you want to perform an operation like this, that is, I'll again write a query, but this time instead of writing this where clause, what I'll do is that I'll transfer this condition to this on statement only. So if I just beautify this a little bit, so here what we are doing, that here also I'm joining my employee table with the department average, but this time the condition that I'm using to join two rows from the table are twofold. The first condition is what, that the department numbers in both the tables should match, right? So if you are joining any row from employee table with any row of the department table, first condition is the department numbers should match. That is what the first condition is. And the second condition is that the salary from the employee table should be more than the respective salary from the department table, right? So for whichever department you are joining, whatever is the average salary for that department, the current salary should be higher than that. So this will allow you to do a check and join the rows simultaneously. So it will only join the rows in which both the conditions are satisfied now, wherein the department numbers are matching and the salary is more than the department wise averages. So if I execute this query now, it will also give me the same results, but the execution time of this second query will be much faster as compared to the first query, because in the first query you are first joining both types of rows, that is the rows in which the salaries are lesser than the average and the salaries which are more than the average, and after that you are doing a filter operation, so which is not the optimal way of doing it. There are bunch of other optimizations as well that people have. You can go through those optimizations as well, right? So these are the main strategy that you can devise when you build a subquery. So determine if a subquery is needed or not, because a lot of times you don't even require a subquery in order to perform a task. If you require a subquery, then only go for writing a subquery, right? If you don't require to have a subquery, that is, you can perform the task using join or a simple join, because usually a lot of times a task which you think is required to be done by subquery can also be performed using a simple join operation. So go with the join here, right? So don't go with the subquery because it will take more time to execute and more resources to execute. Right? So if a subquery is needed, then only go for a subquery. If you can perform the same task using a simple join operation, go with the join clause. Don't go with the subquery. Then you determine where you have to place it. We have 4 types of subqueries that I've already discussed: nested, inline, with, and scalar. You determine what type of subquery is required depending upon the example. Then try to execute the subquery as independent query first. So if you are writing a simple subquery, I've already said this, that in an independent subquery, in a simple subquery, the subquery is independent of the outer query. That is, you can execute it completely independently from the outer query. So try to execute the inner query first and see if the results of the inner query are correct or not. If you are satisfied with the results of the inner query, then join it or combine it with the outer query. That will allow you to debug the query much easier, right? So that the debug process becomes much easier. And finally, it's always a good practice, if you are creating a temporary table or something, right, give it a sensible name, right? Because that name will be required to be used in the subquery later on. So therefore, whenever you give a name to any derived table, use sensible names for those derived tables. Don't use names like temporary table or something like temp or ABC or any other random names. So always use proper names that suffice what that table stores. In all the examples that I have shown, wherever I'm creating a derived table, I have always given a proper name to that table, which can make it clear for me later on what that table contains. And finally, run the entire query and see if the results are as per your expectations or not. This is a strategy that everybody has to follow whenever you want to run a subquery in MySQL, and not just MySQL, any other SQL flavor that is there for the